It's section 2.8 in Advanced Algebra 2, and we are graphing not quite lines. How is this different so far than just a plain old line? The symbol is not an equal sign. It's a less than sign. Those are inequalities, right? To graph inequalities. Our goal, get y all by itself first, okay, is y all by itself. And that's a linear situation, correct? So if you remember way back to Algebra 1, we're going to treat this like it was a line. What's the y-intercept? Let's start there. What's the slope? Rise 3, run 1, rise 3, run 1, rise 3, run 1. I'm a fan of putting 4 points, if possible, on that. But when we connect our dots, this is the only mistake that we usually make, is we have to determine if the line counts or if the line doesn't count. That's solid line versus dashed line. And all that is if this has an equal to bar, the line will count. If it does not have an equal to bar, the line will not count. So should I put a solid line or a dashed line? Dashed line, meaning any point on that line really doesn't satisfy this situation. For example, I want to explain it right the first time. If I put the point 0, 1 in here, right, to where 0, 1, would you all agree that 0, 1 is on that line right there? That will not make this inequality true. If I put 0 in for x and 1 in for y, 1 less than, what's 3 times 0? 0, and then plus 1 is 1. Is 1 less than 1? Yes or no? Is 1 less than 1? No, meaning that this point does not satisfy the situation. We are trying to find all the points that satisfy this situation. There will be an infinite amount of those points. But where are they located? So I will show you the test point idea, and then I will show you the shortcut around the test point idea. It says, let's find a point that's not on the line for sure. You don't want to use the line. Let's find a point that's not on the line and test it out. How about 0, 0? Is 0, 0 not on the line? Let's put 0 in for x and 0 in for y and see if it works or it doesn't work. When we put a 0 right there, and then what's 3 times 0? Add 1 to it. Is 0 less than 1? Yes or no? That means that this point satisfies this inequality. And where is it located in relation to the line? Is it above the line or below the line? And back in Algebra 1, there are students who had a very hard time with above versus below. So would you all agree that that arrow is above the line and this arrow is below the line, right? Up versus down. You with me on that? Meaning this point right here, since it was below the line, satisfied, every point below that line will satisfy that situation. So we're going to just do a light shade. Take your straight edge, if you will, and put it on the above the line right here, and use it for like a guide so you don't go out of bounds. And just lightly shade right there. Don't waste a lot of pencil. Just give me a light shade and say all of those points satisfied. Cool? Now here's the shortcut. If y is all by itself, all you have to do is look at, isn't that symbol mean less than? And what does less than mean to you? Above or below? Below the line. Next, is y all by itself on one side of the equal sign? So let's get it all by itself. Oh man, there's rules though when you got to switch that inequality symbol sometimes. When do you switch that symbol? If you multiply or divide by a negative, what's our first move? Subtract 4x. Will I switch the symbol when I do that? Nope. And then don't put plus 0. Right? We don't need that. We cool with that? Didn't have to switch the symbol. That's in slope-intercept form. We'll treat it like it was a line. What's the y-intercept? 0. Rise 4. Run 1. Excuse me, my bad. It's down 4. Down 4. 1, 2, 3, 4 to the right 1. Down 4. Into the right 1. And that's enough. 3's fine. You can go up 4 to the left 1, but we have line graphing experience at our level, you know. I think we get the gist. Solid line or dashed line, though? So at least give me 3 dots is what I'm saying. Solid line, right, which that should be solid. My bad. Solid line, nice and solid right there. And then what is that symbol since y is all by itself? Less than or greater than? And will that mean shade above or below? Below. Light shade. I'll use my straight edge for a guide. Below the line. And then our inexperience comes in. Is y all by itself on one side of the symbol? Yep. How many variables are in here? 2 variables or 1 variable? 1. Is this going to be a vertical line or a horizontal line if the only variable is a y? Horizontal. I'm going to graph myself. What kind? Solid or dashed? And what will it go through on the y-axis? 5. Just like that. Horizontal, dashed line, going through 5, because y is 5 every time if that was an equation. Y is 5. 5 doesn't count, though, so that's why it was dashed. And then less than, above or below. Below. Don't waste a lot of pencil on that situation. Just make sure I can kind of see it. Next guy. Only 1 variable, so it is not oblique. Will this be vertical or horizontal? Vertical, and it'll go through what on the x-axis? -3, solid or dashed? Dashed. And then you have to do common sense after that. There is no above or below a vertical line. You can't go above it, you can't go below it. But can you think of it as left and right now? Left and right of it? If that's a greater than symbol, where are all the x values greater than -3? To the right, to the right, to the right. Newt, 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 newt. 2 more. We'll do them together. Is y all by itself on one side of the symbol? Yep. Cool. Slope-intercept form. What's the y-intercept? A lot of people want to try to clear the fractions. You can't do that. You got to have y all by itself. You can't clear the fraction. What's the y-intercept? Not 3/2. -3/2. Can you think of it as a fraction? What's -3/2 as a decimal? I said fraction. I meant to say decimal. What is that? Negative what? So, boom, right there. -1.5. Get used to it. Everything you've graphed up to this point has been so pretty for those y-intercepts. Cool. -1.5 is about right there. What's the slope? X can never be a part of the slope. It's 1/2. Isn't there really a 1 right here? 1/2 is the slope. So I need to rise 1 and run 2. Oh my goodness. If I'm a half unit down here, how do I rise 1? How about you go up to here? Isn't that up a half and up another half, which is up 1? And then how far to the right will I run? Boom, boom. And then rise another 1, which would get you up to here, and run 2 units. So you can still rise and run. You just got to be careful. Where'd you start at? I started at -1.5. Wouldn't I go up to -0.5 and etc.? Solid or dash? Yep. Watch out for that. That's our big error, the old solid or dash. That's why we use pencil, so we can erase if we accidentally connect it. And then where will we shade, above or below? Now, let's do some thinking. Where did this move according to where its parent function started at? Who is this guy's parent? Parent is y equals x. Did this get reflected over the x-axis? Yes or no? Nope. We're looking at this number. Didn't happen. Did it get translated at all? Translated. Did it move left or right at all? Did it move up or down at all? And where did it go? Down 3/2, correct? Didn't that point 0, 0 move down here? Correct? And then did there be any horizontal or dilation? Let's go dilation next. Is there a dilation at all? Use your new purple note card. Is there a dilation at all? Here's what it is. We got y is less than 1/2 x minus 3/2, if you like it a little pretty. Was there a dilation? Vertical dilation or horizontal dilation? Vertical. Did it get vertically compressed or did it get vertically stretched? Because that's less than 1, correct? This is not as This was the parent guy right here. Let's switch colors. Here's the parent guy right there. Didn't that thing get translated 3/2 units down and get vertically compressed by a factor of 1/2? Right there is what happened. Next. Ooh, me no likey. Got to get y all by itself, but let's get rid of these nasty decimals. Let's think about what we could multiply by. This is really what as a fraction? 1/2. This is really what as a fraction? -1/4. And this is really what as a fraction? 3/2. What would you multiply everything by to clear the fractions? Take it all times 4. That's what I'm going to do first. Take your times 4. 4 times 1/2 is 2. And there's an x with it. And then 4 times a -1/4 is what? -1. How about -1, right? -1. Symbol stays the same because we're not multiplying by a negative or anything like that. And 4 times 3/2, 2 goes into 4 how many times? Twice. Take that times the numerator and you get a 6. Now we can get y all by itself real easy in this one. First move is to do what? Subtract the 2x. So, oh man, what's left if I subtract the 2x? -y. Should I switch the symbol if I subtract 2x from both sides? No. Is everyone cool with -y being less than -2x plus 6 so far? Is y all by itself? No. I got to get rid of that negative, and how do you get rid of the negative? You could either multiply by -1 or divide by -1 and get you the same thing. So this would become a y, this would become a 2x, that would become a -6. Symbol, stay the same or switch? Got to switch. Got to switch because we multiplied by a negative. So we'll graph -6 down here, rise 2, run 1, rise 2, run 1, rise 2, run 1, solid or dash? And then here's our big mistake, where we made it in Chapter 1, where we made it in Algebra 1, is we got to shade, above or below. But do you shade based on the original symbol, or the one that you just put in slope-intercept form? You got to look at this guy. What's the symbol? Sorry, what's the symbol? Greater than or less than? Greater than. Even though the original one was a less than, we simplified it to be this, so that means shade above that. Are we good if those were lines? Awesome. That was just a warm-up. Is this going to be a line? Nope. It's not going to be a line. What's it going to be? It's going to be an absolute value v. Do you also see that there is no equation right here either? This is an inequality, right? Now what I want to do is preview it before we graph it. How will RV look based off the parent function? Let's go down the new purple note card. Step number 1. Will this get reflected over the x-axis? Yes or no? Not going to happen. So what's our v going to look like? Open up or open down? It's still going to open up. Will it be translated anywhere? Where will it be translated to? 1 unit to the right, correct? And 0 units up, if you will. Will there be any kind of dilations to this bad boy? Will it be vertically or horizontally affected? Vertically, that will be what? So that means if it's vertically stretched, it's going to look how? Skinnier or fatter? Skinnier, right? And will there be reflections over the y-axis? Yes or no? Not going to happen. Now, looks like when I picked up your homework quizzes, we remembered how to graph an absolute value. What number goes by the asterisk? Make me a little table if you haven't done that yet. What number goes by the little asterisk? Whatever makes what's inside the bars turn out to be, and what will this turn out to be? 1. Didn't you say that that's going to move 1 unit to the right? Correct? What is this number right here? Oh, that's a positive 1, which will move us 1 unit to the right when we start graphing, correct? And then we've got to figure out what y would turn out to be. If we put 1 in there, that would be 0. 3 times 0 is 0. Oh, unbelievable. What was our horizontal shift? What was it? 0. It went not up and not down. This point right here is your translation. 1 to the right, 0 units up. Correct? Next guy, right here. What do you want to do? 2 and 3, and then 0 and -1. Cool. Let's substitute those in. We only have to do half of them based off the symmetry, correct? So if we put 2 in, 2 minus 1 is, take it times 3, and you get a, what do you get? 3. If we put 3 in, you got to do 3 minus 1, which is 2, and the absolute value of that is still 2. Take it times 3, what do you get? 6. What's this guy going to be right here? 3. This guy's going to be a 6. Let's plot those points. 1, 0. Ooh, interesting. 2, 3. And 3, 6. Now, don't connect the dots yet. This is not an equation. This is an inequality. Solid or dashed connections. Because that has an equal to bar, we will be allowed to use the solid. Okay, so let's connect them together with solid. Did it shift 1 unit right and stretch vertically by a factor of 3. And let me show you the original dude real quick before we finish this problem. Here's the original dude. Isn't this where the parent's vertex is really at? And then it does this. This has that like a slope of 1, if you will. Do you see that the slope is now 3 over 1 instead of 1 over 1? Didn't it stretch vertically by a factor of 3? The thing is, though, we're still not done with this problem because it was an inequality, meaning we got to shade. Where would you shade in relation to that v, since y is all by itself? Above the v or below the v? So, below the v. Next, oops, had it. How will this guy relate to the parent? I want you and Pal to think of that while we pause the video. Translated. Where's it translating? 1 unit up. Is there any dilation? Nope. Is there any reflecting over the y-axis? All this is we're taking our normal OV and moving it up 1 unit, correct? So what's our x value by the star? What's it going to be? 0. It's whatever this turns out to be 0. And if x was 0, meaning it did not move left or right, correct? It did not move left or right, what would y turn out to be? 1. Doesn't that mean that it moved 1 unit up? Correct? Then we put a 1, 2, and a -1, -2. Table and graph. Plot them, and then realize if you should use solid or dashed. Remember, you're not always connecting them together with solid information. Solid or dashed. That's the big mistake on these. Are we down with solid? Yep. Shade above it or below it? Above, meaning inside the V, if you will. Those are where all the solutions are that make this a true inequality. Would this point of 0, 4 satisfy the situation? What do you think? 0, 4, would it make it true or not true? Well, did we shade in there? So should it work or should it not work? Well, let's see. I'm putting 0 in for x, and what in for 4? Or what in for y? 4. What's the absolute value of 0? Add 1 to it. Is 4 greater than or equal to 1? That point satisfies the situation. Next, talk to me. What don't you like about it? Y is not all by itself. How can we get y all by itself? Just what you think. You just add 2. 2 absolute values of x get added over. So will I switch the symbol when I add 2 absolute values of x's over? Awesome. Feeling good? So we'll graph it. Figure out what will make x 0. What's inside the bar 0, sorry. And that would be 0. One, 2, -1, -2. When I plot my points, I'll put a 1 in, and that would turn out to be 5. Put a 2 in, that'll turn out to be a 7. 0, 3 up here. 1, 5 up here. 2, 7 up here. Isn't that thing skinnier than normal, right? Like twice as skinny because of that factor of 2 on the outside. Solid or dash? Watch out for that. Dash situation. Shade, above or below? What? Above. I thought you said both. I was like, how can you shade on both spots? Everything works but the V. Good? Couple more. Like I said, real easy day. Next guy. Is y all by itself? Get y all by itself. Do you have to switch the symbol when you subtract absolute value of x over? Where will the minus be? On the outside or inside? Outside. Cool. Here. X is, the x value of the vertex will be what, my friends? 0. What will be the y value of the vertex? 4. There's your translation right there. It's where did the point 0, 0 go to? It became 0, 4, right? This thing got translated 4 units up. Then we put a 1 and a 2 and a -1 and a -2. How's this thing supposed to open again, though? Refresh my memory. Down. We put 1 in. Absolute value of 1 is 1. But isn't that negative on the outside? Correct? So that makes it a -1 plus 4, which is 3. Correct? And if we put 2 in, we would get 2 back. So 0, 4, 1, 3, 2, 2. And it should be opening down. Solid or dash? Solid. Shade above it or below it. The only way above below shading trick works is if you get y all by itself. Otherwise, you got to use test points. But we want to graph. We like y all by itself, so above, 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 above. Cool? Ooh, interesting. We got to get y all by itself on one side of the equal sign. Folks, there's this plus absolute value of junk and the times 2 in front of the y. What do we get rid of first? The stuff being multiplied by y or added to y? Get rid of all adding or subtracting. No, we need to subtract that guy over first. All right? So I hate that there's no room underneath there. I'm going to come over here and put 2y. Should the symbol switch if I do that? Less than negative outside the bars x plus 1 as absolute value. Good? So far, so good? Now we got to get rid of times 2 by dividing by 2. So when we divide by 2, first question, will the symbol switch? Nope, this will become a y. Symbol stays the same. And all we're dividing by 2 is whatever that a value is right there. This is just a group of stuff. We're taking this number, which is really a -1, correct? And dividing it by 2, what would you get? -1/2 times the absolute value of x plus 1. Is everyone cool with where the divide by 2 went with? Right? Okay. So -1 goes here for the x. And then y would turn out to be what? 0. Because it shifted not up and down at all. Ooh, man. Numbers to pick. See that stupid divide by 2 out here? I would like to go up by 2's then with this number. I know it's a -1, but I don't want to go to -2 because that only went up by 1. You with me? Go up by 2. What would you go up to if you went 2 units forward from -1? +1. Whatever that denominator is, you want to just kind of say that's what I want my multiples to go by. So the next one after that would be a 3, correct? You could put those other numbers, but you get decimals out of that situation. We don't like decimals. So if we put 1 in for x, wouldn't we have 1 plus 1 inside the bars, which is 2. Absolute value is still 2. What's 2 times a -1/2? -1. Came out nice because we picked a multiple of 2 in there. You put a 3 in there, you get a 4 to shoot out of the bars. 4 times the -1/2 is -2. Watch your signs, right? Watch your signs. Other numbers here, you got to be careful. You got to be symmetrical. We still got to go down by 2. What's this x value got to be? -3, then to -5. You got to have symmetry in your x's. That way the symmetry shows up in your y's. If you went up by 2 this way, you got to go down by 2 that way. Dashed, right? And then shade. That's not right, is it? -1. +1. Yeah, that's okay. Yeah, down. I got you. What? Mine was wrong, video people. Here's the right one. So here's what it should look like. My bad. And it didn't it? Here's what I had. Not fatter, because I plotted my points wrong, is what I did. But this is what it looks like. There. Sound oakley dokley do? Uno mas. What's the first step? Get y all by itself. Where would you like to put this minus absolute value stuff? Before the -1 or after the -1? Before it. Slope-intercept form, if you will. Are we good with that? Yes, no, maybe? Tricky one. Let's roll with what will we put in here? 0? What do we want? -2? 2, right? I'm looking back to the original one now. 2, right? What would y turn out to be? Well, if we put a 2 in there, that'd be 0, and then that's -0, which is still 0. Then take away 1. What do you got? And isn't that what you told me your translation would be, or was it not what you told me your translation would be? Is it, or is it not? Pretty sure she said left 2. Pretty sure she said left 2. Isn't it left 2? How come that didn't become a left 2? Because it got reflected over the y-axis, right? So don't get in a bad habit thinking that your translation is always that point. It only is if it doesn't get reflected over the y-axis, okay? So very tricky. Cool with that? Fill it out. Do we got any crazy fractions in front of there? Nope. So I'm going to go up by ones. 3, 4, 0, 1, 0. If I put a 3 in there, I'd get 2 minus 3, which is negative 1. But I need its absolute value, which is positive 1. But I got a negative on the outside, which makes it back a negative 1. Take away 1, which is negative 2. Now, if you graph this, dude, and it starts opening up, that means you did all your algebra wrong. Correct? It's like, whoa, dude, this should open down. That's why I'm trying to train you to look at it before you graph it. It's like, am I doing my algebra right? This has got to open down, correct? If you're putting the wrong numbers in there or getting wrong values to shoot out, you just got to go back and redo your algebra. 4, if we put a 4 in, you get 2 minus 4, which is a negative 2. Absolute value of that is a positive 2. But then it's going to be a negative because that negative on the outside. So you got a negative 2 minus 1, which is negative 3. 2, negative 1, 3, negative 2, 4, negative 3. Solid or dashed? Dashed. Shade above or below.